Our lesson for today is sum and difference identities. In order to understand this lesson, you will need these formulas. Make sure you memorize these things because they'll be very important in our lesson later on. Before we move on to the lesson proper, here are the special angles in degree and in radian. Take note of these things. You can probably write them down or list them because they will be very important in our lesson later on. Finally, in this lesson, you will also need these angles and the exact values of the x, y, and r because you will need it for getting the exact values, especially the 30 degree, 45 degree, 60 degrees, 90 degrees, 0 or 360 degrees, 180 degrees, and 270 degrees, the values of these things. Also, you'll need to know how to get the reference angle. We expect that you already know how to solve for it because it's in the lesson of the past. So, take note of these angles and their values because you will really need it later on. So today, our first problem will be is finding the exact values of cosine 15 degrees. So, we have to find two special angles which the sum is or difference is 15 degrees. So, in this problem, we're going to use 45 degrees and 30 degrees. So, since 15 degrees is equal to 45 degrees minus 30 degrees, we can assign the value of A to 45 degrees and B to 30 degrees. So first, we have to write the formula in order to make things clearer for us. So cosine 15 degrees is equals to cosine 45 degrees minus 30 degrees. We also have to write down the general formula to make it much clearer for us. Cosine A minus B will be equal to cosine A cosine B plus sine A sine B. So all we have to do now is substitute the values in the formula and insert things. So what we'll have by now will be cosine 45 degrees, cosine 30 degrees, plus sine 45 degrees sine 30 degrees. So now that we have that, we have to get the exact values of cosine 45, cosine 30, sine 45, and sine 30. So if we get those values already, we'll be having square root of 2 over 2 plus times square root of 3 over 2 plus square root of 2 over 2 times 1/2. So after that, we'll be getting square root of 6 over 4 plus square root of 2 over 4. And we can join them together with one denominator. And finally, the answer would be square root of 6 plus square root of 2 all over 4.
In problem number 2, we will find the exact value for sine 165. Since we know that 165 degrees is equal to 120 degrees plus 45 degrees, we will put A as 120 degrees and B as 45 degrees. So now we know that sine 165 degrees is equal to 120 plus 45. We'll now put the general formula for the sum identity for sine. So that will be sine A plus B is equal to sine A cosine B plus cosine A sine b. We'll now substitute the values that we had earlier. So this will be sine 120 plus 45. It will be sine 120 cosine 45 plus cosine 120 sine b, which is 45 degrees. Take note that the reference angle for 120 degrees is 60. We'll now substitute and get the exact values of the following. For sine 120, it would be square root of 3 over 2 multiplied by cosine 45, which is square root of 2 over 2, plus cosine 120, which is negative 1/2, multiplied by square root of 2 over 2. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Plus negative 1 times square root of 2 is negative square root of 2. 2 times 2 is 4. We'll now combine and simplify the terms, which will bring us to square root of 6 minus square root of 2 over 4. That's the answer for this problem.
We find the exact value of tangent 345. The general formula for the sum identity for tangent is tangent quantity a plus b equals tangent a plus tangent b over 1 minus tangent a tangent b. Next, we have to look for two special angles that would either give the sum or difference of 345. We can use the special angles 300 and 45. So we have tangent 345 equals 300 plus 45. Let A be 300 degrees and B 45 degrees. Then we substitute the values according to the formula. Tangent 300 degrees plus tangent 45 degrees over 1 minus tangent 300 degrees tangent 45. Then we get the exact values of the angles. So now it's negative square root of 3 plus 1 over 1 minus quantity negative square root of 3 times 1. Then it becomes negative square root of 3 plus 1 over 1 plus square root of 3. Since there is a square root in the denominator, we must rationalize it. So it becomes quantity 1 minus square root of 3 over 1 plus square root of 3 multiplied by 1 minus square root of 3 over 1 minus square root of 3. Then we use the FOIL method. So it becomes 1 minus 2 square root of 3 plus 3 over 1 minus 3 equals to 4 minus 2 square root of 3 over negative 2, which is equal to negative 2 plus square root of 3.
In problem 4, find the exact values of cosine quantity a plus b and cosine quantity a minus b if sine is equal to 3 over 5 and tangent if sine A is equal to 3 over 5 and tangent B is equal to negative 5 over 12, and A is in between 0 and pi over 2, and B is in between pi over 2 and pi. First, we have to find the following values before we use the identities. Cosine A, sine B, and cosine B. We have to find that before we use the identities for cosine. To find cosine A, we have to use the Pythagorean theorem. Since A is just in between 0 and 90 degrees, since pi over 2 is basically just 90, A is therefore the first quadrant. So we draw a right triangle in the first quadrant, and we substitute the values. So then 5 and 3, we use a Pythagorean theorem here. So 5 squared is equal to 3 squared plus x squared. So we're going to get 25 minus 9 equals x squared. And when we square root that, we get 4. So x is just basically 4. So then we have cosine A is just basically 4 over 5. Next, we get sine B. In order to get sine B, first we need to draw the quadrant where B is in. Since pi over 2 is just 90 and pi is just 180, B is in the second quadrant then. And then we substitute it. Since it's in the second quadrant, the adjacent side needs to be negative, so it's negative 12. And the opposite is positive. So it's 5 and negative 12. And then we use the Pythagorean theorem again to get this side. So we have, let's use R. R squared is equal to negative 12 squared plus 5 squared. So R squared is equal to 144 plus 25. So it's 169. If we square root that and this, we get 13. So the hypotenuse is just basically 13. And if we just use the value of this and what's given in the problem, we can make sine into 5 over 13, and cosine B is equal to negative 12 over 13. So then, after that, let's use the identities. To find cosine A plus B, we have a formula. It's cosine A cosine B minus sine A sine B. So we substitute it. So 4 over 5 times negative 12 over 13 minus 3 over 5 multiplied by 5 over 13. Okay. So then after that, it's negative 48 over 65 minus 15 over 65, which is negative 63 over 65. So cosine A plus B is negative 63 over 65. And that's the answer. Next, in order to get cosine A minus B, we need to use the formula again. It's cosine A cosine B plus sine A sine B. And let's substitute that again. It's gonna be 4 over 5 times 12, negative 12 over 13 plus 3 over 5 multiplied by 5 over 13, which is negative 48 over 65 plus 15 over 65, which is negative 33 over 65. And that's the answer. So cosine A minus B is negative 33 over 65. And that's the answer. These two are the answer. Yay.
Problem number 5. Find the exact values of sine A plus B and sine A minus B if sine A is equal to square root of 3 over 2, tangent B is equal to 15 over 8, and A is between pi over 2 and pi, and B is between 3 pi over 2 and 2 pi. Find cosine A, sine B, and cosine B. First, find cosine A. Note that sine A is equal to square root of 3 over 2. And A is in the second quadrant, so y is equal to square root of 3 and r is equal to 2. Calculate for x. So x is equal to positive negative square root of 2 squared minus square root of 3 squared, which is equal to positive negative 1. Since A is in the second quadrant, x is equal to negative 1, thus cosine A is equal to negative 1 half. Sine A is equal to negative 1 half. We now have to look for sine B and cosine B. Note that tangent B is equal to negative 15 over 8 and B is in the fourth quadrant. So y is equal to negative 15 and x is equal to 8. Find r. R is equal to square root of 8 squared plus negative 15 squared, which is equal to 17. Thus, sine b is equal to negative 15 over 17 and cosine b is equal to 8 over 17. Sine a plus b is equal to square root of 3 over 2 times 8 over 17 plus negative 1 half times negative 15 over 17. Then multiply. Square root of 3 times 8 is 8 square root of 3 over 17 times 2 is 34 plus negative 1 times negative 15 is positive 15 over 17 times 2 is 34. And simplify. So the answer is 8 square root of 3 plus 15 over 34. So we now proceed to sine a minus b. Sine a minus b is equal to square root of 3 over 2 times 8 over 17 minus negative 1 half times negative 15 over 17. Multiply. 8 times square root of 3 is 8 square root of 3 over 17 times 2 is 34 minus negative 1 times negative 15 is positive 15 over 17 times 2 is 34. So the answer is 8 square root of 3 minus 15 over 34. So that's it. Sine a plus b is equal to a square root of 3 plus 15 over 34. And sine a minus b is equal to a square root of 3 minus 15 over 34.
Here's our last problem. Find the exact value of tangent quantity a plus b if sine a is equal to 4 over 5, cosine b is equal to negative 5 over 13, angle a is between 0 and pi over 2, and angle b is between pi over 2 and pi. To find tangent A, note that sine A is equal to 4 over 5 and A is in quadrant 1. Use y equals 4 and r equals 5 to find x. First, we use the Pythagorean theorem to determine x. We then sketch the triangle with the respective side lengths. X is equal to the positive negative square root of 5 squared minus 4 squared. Therefore, x is equal to 3. Since A is in the first quadrant, x is equal to 3 and tangent A is equal to 4 over 3. To find tangent b, note that cosine b is equal to negative 5 over 13, and b is in the second quadrant. We use x equals negative 5 and r equals 13. We then sketch a triangle with their respective side lengths. Then we find the value of y using the Pythagorean theorem. Y is equal to the positive negative square root of 13 squared minus quantity negative 5 squared. The result will be positive 12. Sine b is in quadrant 2, y equals 12, and tangent b is equal to negative 12 over 5. We now start with the formula, which is tangent quantity a plus b is equal to tangent a plus tangent b over 1 minus tangent a times tangent b. Let us now substitute the values for each variable. The equation will now be equal to tangent quantity a plus b is equal to 4 over 3 plus quantity negative 12 over 5 all over 1 minus 4 over 5 times quantity negative 12 over 5. It will then be simplified into 20 minus 36 all over 15 all over 21 over 5. You then reciprocate 21 over 5 and multiply it to negative 16 over 15. You will get the final answer, which is negative 16 over 63.